Okay, ladies and gentlemen, today we're going to talk about writing and solving absolute value equations. So, when solving absolute value equations, well, the first thing we need to do is remember what absolute value is. Absolute value is the distance a number is from zero. So, it's just how many units away it is. So, -3 is 3 units away from zero, and so is +3. It's 3 units away from zero. So the absolute value of 3 is 3, and the absolute value of -3 is 3. So basically, any number or any expression inside absolute value bars is going to be positive. So let's take a look. The first step in solving is to solve the equation twice. So that means we're going to write it down twice. But the second time we write it down, we're going to write it down as a negative answer. So we're going to solve it twice, once as a positive and once as a negative. We're going to write our two answers in set notations because our solution is the set of those two numbers. And the third step is to graph on a number line if it's required. So let's just jump right in. Our first equation says the absolute value of the sum of n and 7 is equal to 5. So step number 1 was to write it down. We're going to solve it twice. Once with a positive answer and once with a negative answer. The inverse operations on both sides are going to be the same. On this one, since it's n plus 7, I know I have to subtract 7 from both sides. Well, we didn't change anything in this expression, so we're going to subtract 7 on both sides in this one. When we do the subtraction over here, we're going to end up with n is equal to a -2. When we go on the other side and take care of the inverse operation, since those cancel out, we're going to be left with n is equal to -12. So our solution set would be the numbers -2 and -12. If I have to graph it on a number line, if you have to graph it for me, all I need to see is a number line with at least 3 numbers on it. The 2 you need, and either something in between or 0 if it's close by. So I've got, we've got -12 down here. We go on towards 0, we have a -2, and then we have 0, and we have dots on both -12 and -2. If we want to check it, let's just plug those values in. When I plug in -12 for n, that's -12 plus a +7, which is a -5. But we're talking about the absolute value of -5. Well, the absolute value of -5 is +5. So -12 is the solution. When we plug in the -2 for n, -2 plus 7 is 5, and the absolute value of 5 is 5. Let's take a look at another example here. This one is just a 2-step is the only difference. It still solves like any 2-step equation. It says the absolute value of 3z minus 3 is equal to 9. So we're going to write it down twice. Once with the +9 as our solution, our answer, and once with a -9. And then we just go through the steps to isolate z. So since it has multiplication and subtraction, we know in a 2-step equation we're going to undo the subtraction first. So I'm going to add 3 to both sides in both equations. When I do so, on the side with +9, I end up with 3z is equal to 12. On the side where -9 was the answer, we end up with 3z is equal to a -6. Our next step in isolating z is going to be divide by 3. So when we divide by 3 on this side, we get 3 divided by 3 is 1, 1 times z is z. So we have z is equal to 12 divided by 3, which is 4. So we have z is equal to 4. On the other side, when we divide by 3, well, it cancels out with the z, so we just have z left over. -6 divided by 3 is a -2. So we have the solution that z is equal to -2. So our solution set would be the numbers -2, +4. If we had to graph it, all I would expect to see is 3 numbers on my number line. So we've got -2, 0, and 4. And -2 and 4 have a dot on the number line indicating that those are the solutions. Let's plug it in just to check like we did on the first one. If I plug in -2 for z, I have -2 times 3 would be -6. -6 take away 3 is -9, and the absolute value of -9 is 9. So that solution works. Well, let's take a look at +4. If we plug +4 in for z, we have 3 times 4, which is 12. 12 minus 3, which is 9. And the absolute value of 9 is 9. So it works. Okay? Let's take a look at this example because it's got something a little different. It says the absolute value of 4n minus 1 is equal to -6. Stop and think about that for a minute. Didn't we say that the absolute value of anything has to be a positive number? So is there any number that we can plug in for n that will work? I don't believe so. And so when we do this, we're going to end up with the empty set. There's no number that I can plug in for n that will make that statement true, because the absolute value of anything is going to be a positive number. Okay? Let's look at a practical example for absolute value equations. This one says the temperature of an enclosure for a pet iguana should be about 80 degrees Fahrenheit, give or take 5 degrees. And it asks us to find the maximum and minimum temperatures. Well, we know that it should be 80 degrees plus or minus 5 degrees. So minus 5 degrees would put us at 75. Plus 5 degrees would put us at 85. So let's take a look. The distance from 80 to 75 is 5 units. The distance from 80 to 85 is 5 units. That's our give or take part, okay? So our solution set would be, when we find the maximum and the minimum, would be the numbers 75 and 85. If we write this as an absolute value equation, we're going to end up with an equation that says x minus 80, or the absolute value of x minus 80, is equal to 5. Let's talk about where those numbers come from. Let's look at our number line. I get x minus, okay, but x minus what up here? Well, would you call that the midpoint? The 80 is the midpoint in that range of degrees. So I'm looking at the absolute value of x minus the midpoint is equal to 5, the 5 units give or take. So we can write a formula for absolute value equations, which says the absolute value of x minus the midpoint equals the give or take. Let's put this to use. Okay? On this top number line, it gives us a -2 and a 4. We need to find the midpoint. Well, it's 6 units away. There's 6 units. So if we count 1, 2, 3, if I put a point here, is that the midpoint? Well, how many units is it that way? It's 3 units. How many units is it this way? Well, it's 3 units. 1, 2, 3. So our give or take is 3. What's our midpoint? Well, our midpoint is 1. So if we use that format, if we say x minus the midpoint, the absolute value of x minus the midpoint is equal to the give or take. Okay? Well, let's plug in our numbers. That would be x minus, what's our midpoint? 1, okay, is equal to the give or take, so that would be equal to 3. If you think about this, if we solve it for a positive 3, we'd add 1 to both sides and we'd get 4. If we solved it for a negative 3, we'd still add 1 to each side. Well, negative 3 minus 1 is equal to that negative 2. So our formula worked. Okay? Let's take a look at this next example. And this one says it's got a point at 11 and a point at 19. Well, how many units apart is that? 8 units. So if I count 1, 2, 3, 4, and put a point here, 1, 2, 3, 4, so I'm 4 units this way, I'm 4 units this way, so my give or take is 4. My midpoint is 15. So our absolute value equation would be x minus the midpoint, which is 15, okay, is equal to the give or take. Well, our give or take was 4. So if we do a quick solve of that in our head, wouldn't we add 15 to both sides? Well, 15 plus 4 is 19. If I make that a negative 4, 15 plus a negative 4 is 11. So we've solved that. And that's a wrap. I'll have to cut that out. But I can do that.